Hello everyone. So already we discussed the concept related permutations and combinations. Now we solve some problems based on that permutations and combinations, right? So we discuss all the concepts. So all vowels come together, all boys sit together, all girls sit together. That type of questions, and all never come together, and no two boys or no two vowels sit come together. Those type of questions are discussed. Similarly, in the combinations also we discuss how we choose. Right, 3% out of 7%, at least at most we discussed those are also right. So now we apply whatever we learned at the concept. Now, first question: how many numbers between 400 and 1000 can be made with the digits 2, 3, 4, 5, 6, and 0? So total given digits are 6 digits. In these 6 digits, you need to find out the numbers from 400 and 1000 in between. In between 400 and 1000 means, so nothing but from 401 to 999. Actually, this is the real meaning. In between 400 and 1000 means that is the yes. Now go for 401 to 999. So all are 3-digit numbers. That's clear. And observe how many ways we can. Repetition is allowed or not allowed means in between 400 and 1000 means 455, 444. So those type of numbers are there. Means definitely repetition is allowed. Why means in the question they did not mention exactly without repetition or each digit can be once. So if it is there, then we solve in different way. Now here, so at starting, if we use 0, then it becomes 2 digits. That's why here we are not going to use 0. Then again, the number is in between 400 and 1000 means definitely number is start with 2 or start with 3. Suppose 2 or 3, I use it is in 200s or 300s. So that's why these 3 digits are not possible at the starting place. So remaining digits are either 4 or 5 or 6. Only 3 possible ways are there at the starting position. Why means according to that given condition in between 400 and 1000. Now here any one of the 6 digit, here also any one of the 6. Total how much? 3 into 6 into 6, 36 into 3, 1088, right? There is a chance of doing mistake. So 1, 2, 3. Other than 0 means remaining are 5. So again 6. 5 into 6 into 6, 180. That is there on the option. But correct answer is not 108. 108. Just observe here. If I write starting 4, definitely remaining 2 zeros. There is a chance of this number is also in this 108 numbers. Why means right here if 4 or 5 or 6 can be used in the starting place. Here any one of the 6 digits, here also any one of the 6 digits means 2 zeros is there is a one possibility. That's why 400 number is also present in 108 numbers, but they are asking about in between 400 and 1000. That's why required numbers are how many means 108 minus 1, 107 numbers are there in between 400 and 1000 by using that digits. That is clear. So very simple, but we need to apply some basics to this question. So there is a chance of doing mistakes like this, and in the options 108 is there, definitely we choose that 108, but still we need to apply some basics to here. In between 400, that's why in the D, whatever the 108 numbers are there, in those 108, definitely 400 is also there. That's why we remove that 400. Then remaining numbers are 107. Now, next question. How many even numbers of 4 digits can be formed with the digits 0, 1, 2, 3, 4, 5? How many even numbers of 4 digits? 1, 2, 3, 4 digits. Even numbers of 0, 1, 2, 3, 4, 5 and 6 also given. No digit being used more than once. Here condition without repetition. No digit being used more than once. Right. Now we will look into that possibilities. Suppose even numbers ending with 0 other than ending with 0. In 2 cases I am going to solve this question. Why means it is not possible. Suppose ending with 0 means, yeah, okay, another case. If not ending with 0 means, again we are not going to start with 0. Why means it becomes a 3-digit number we start with. That's why I am taking two cases. In two cases I solve. So first case is ending with 0. Ending with 0, here always one way. So in the remaining three places, whatever the digits you used, right, no digit being used more than one. So total digits are how many? 0 to 6, 7 digits are there. Already one digit is used here. Remaining 6 digits. Out of remaining 4 digits, 5 digits, then remaining 4 digits. So how many ways are there? 6 into 5 into 4. Ending with 0 even numbers are how many? Means 120. Simple. Ending with 0 are, right, definitely there is only one possible way at the last digit. That's why one way. Remaining 6 digits are there. At first position 6. Remaining 5 are there. Any one of the 5. Remaining any one of the 4. 6 into 5 into 4 into 1. 1. Similarly, case 2. Ending with even digit. Even digits are 2, 4, 6 according to this question. So, how many? Any one of the three I can use at that last under, but at starting I am using any one of the 2 or 4 or 6, so only one digit I used. So 2 digits still there, and total how many are there? 7 digits. So out of 7 here I am using one digit. Then still in the 6 digits I am not going to use 0 here. Why means if I start with 0 then it becomes a 3-digit number. It not so one digit is already used here and 0 is not going to use at the starting place. Remaining are how many means only 5 digits. We can choose any one of the 5. But observe here. So here also one digit used, here also one digit is used. Now 0 is also used in the middle. So that's why 2 digits removed from the 7 digits means remaining 5 digits are there. Out of 5 I can use any one. Here out of remaining 4 I can use any one. 5 into 5 into 4 into 3. 300. So total how many ways means 120 plus 300. 424 digit numbers formed by given condition. So first condition is very easy. Ending with 0, remaining digits are 6, remaining out of 5, remaining out of 4. Okay. But here you need to observe carefully. The last digit is even means either 2 or 4 or 6, 3 ways are there. But we use any one digit at the last. But at starting, we are not going to use with 0. Why means if we start with 0 means definitely it becomes 3 digits, but they are asking about 4 digits. So 0 and whatever the digit last used, those two are excluded, means remaining 5 digits are there. In that 5 we can use any one. Then here starting and last we are using 2 digits means remaining 5 digits and remaining 4 digits. Now 300, total 420. Numbers can be formed based on that given conditions, right? Next one. That right, slowly it will give clarity. Just to try to understand, right? Once we get clarity means very easy to solve permutations and combinations problems. A gentleman has 6 friends to invite. In how many ways can he send invitation cards to them? If he has 3 servants to carry the cards, so 6 friends are there. He has 3 servants. He has 3 servants. In how many ways he send invitation cards? Suppose 6 friends are there. For that first person, maybe 3 servants will go there and invitation cards to that first person. And the second person also, 3 persons go and give invitation cards. For third person also, for fourth person also, for fifth person also. Similarly, for sixth person also. All the 3 servants went to each and every person and giving that invitation cards. So, like that, how many possibilities are there means total 3 into 3 into 3 into 3 into 3 into 3, nothing but 3 power 6 value is 729 ways. So, 729 ways we can invite them. Means suppose only first servant went all, second servant went all, third servant went all 3 servants went all 3 servants went all. Those all are the different types of conditions. Suppose first servant went first, second, third persons. Remaining three are the different. So many possibilities are there. Like that, we formed total. We get 729 ways we can invite them based on the different scenarios. So we have only three servants. If four servants means 4 power 6. Five servants means 5 power 6. Like that, we will calculate. Here also, that repetitions are. They did not mention any right. Condition in the, so clear, every person get only one invitation like that. So how many ways we can invitation cards send to them means total 729 ways. So in that 729, that anyone choose, I mean that person choose any one way, that is the his thing, right? A letter lock consists of three rings. Right, a letter lock, I mean, for suitcases and a cycle lock, so that type of a letter lock consists of three rings, each marked with 10 different letters. So 10 different letters. In generally 0 to 9 digits, 10 digits actually. Here 10 different letters. Okay. In how many ways can an unsuccessful attempt be made to open the lock? Suppose, right, they mention letters. So suppose A to J, suppose A to J, these are the 10 letters. So three rings are there. Maybe I choose A or A B C or A G J, like so different cases. So how many ways means I can choose any one of the 10, here also any one of the 10, here also any one of the 10. 10 into 10 into 10, total 1000 ways we can lock that number, letter lock. So that letter lock can be right marked with 1000 ways. But what they are asking, how many ways an unsuccessful attempt? In that 1000 ways, definitely one is the correct way or successful attempt. So unsuccessful attempts are how many? Unsuccessful attempts are how many? 1000. One is the definitely successful way. Remaining 999 ways are unsuccessful attempts to open that numbered or ring three locked letter lock. Okay, clear? So these are the cases. Very simple. So 10 digits are 10 numbers, 10 letters are there. So 10 into 10 into 10, total 1000. In that 1000, right, definitely in one attempt, that lock will open. That's why we subtract that one from 1000, we get a 399. In a class of 10 students, there are three girls. In a class of 10 students, three girls means remaining 7 are boys. Now, in how many different ways can they be arranged in a row such that no two of the three girls are consecutive? No two of the three girls are consecutive. So no two vowels come together, no two boys sit together, no two girls sit together. In this case, first we arrange other gender or other type. So vowels means consonants, consonants means vowels. First we arrange boys in how many ways? First, arrange boys in how many ways? 1, 2, 3, 4, 5, 6, 7. Right. So total 7 boys are there. So 7 boys can be arranged in how many ways means we know 7 factorial ways. That's simple. Now how many gaps are there? 1, 2, 3, 4, 5, 6, 7, 8. In these 8 gaps, you placed any 3 places that by girls, then that condition is satisfied. So no two girls are seated. But some places boys sit adjacent to each other, but that is no problem. They are asking about no two of the 3 girls are consecutive. So 8 gaps are there, 3 girls are there. How many ways we can arrange them in 7 factorial into 8p3 ways. That is the answer. The options directly is there. Suppose in simplification way means 7 factorial 5040. 8p3 value is 8 into 7 into 6. By multiplication you get that answer. Right? Next one. Very simple question. Now, there are 8 boys and 4 girls. 8 boys and 4 girls are there. In how many ways can they be seated in a row so that all the girls do not sit together. All the girls do not sit together means maybe two girls sit together, three girls sit. Those are possible. That's why when reading the question and understanding is important. Maybe all the girls do not sit together means maybe two girls sit together is a possibility. Three girls sit together possibility. But all the four girls sit together means so. Does it? It is not possible according to that question. So that is the case. Now, so for this case, all never come together. All the girls never sit together. Like this type of questions, we go for total possibilities minus all sit together or all come together. All sit together. Here, all girls. Fine. So all girls do not sit together. So that's why all girls sit together are fine. So now, total 8 plus 4, 12 members are there. 12 members can be arranged in 12 factorial minus all girls sit together means girls are how many? 1, 2, 3, 4. We form a group of that girls. We form a group of that 4 girls and the remaining boys are 8 by 8 plus this girls group considered as single unit. 8 plus 1, 9 can be arranged in 9 factorial into that 4 girls again shuffled themselves in 4 factorial. Maybe those can be rearranged again themselves. That's why 4 factorial. Now, right, simplify this. 12 factorial minus 9 factorial into 4 factorial. So, simplification like 12 into 11 into 10 into I am writing 9 factorial. Why means right. So 9 factorial in both numbers I took common. So 9 factorial is common. Then 12 into 11 132 into 10 1320 minus 4 factorial value is 24. Nothing but 9 factorial into 1296. So answer is 1296 into 9 factorial. So just observe option. 1320 into 9 factorial is there, 1344 into 9 factorial is there, 1296 into 12 factorial. Correct answer 1296 into 9 factorial. So for this, okay, 12 factorial minus 9 factorial into 4 factorial up to now very easy after discussing so much of concept. Then again this simplification is matter. They are given in the 9 factorials. 3 options are 9 factorial. That's why I convert this 12 factorial into 9 factorial then simplify like this. Next one. In how many ways can 10 examination papers be arranged so that the best and worst paper never come together? So total how many papers are there? 10 examination papers. In this best and worst, how many papers here? 2 papers. So these 2 papers never come together means again same total minus best and worst come together. Best and worst come together. Total 10 exam papers are arranged in how many ways means 10 factorial ways minus total 10 factorial ways. Best and worst 2 papers form as a group. The remaining are 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 1 9 factorial. Then 2 papers again best worst and worst best. So themselves arranged in 2 factorials. Again we write like this 10 into 9 factorial minus 9 factorial into 2 factorial. So 9 factorial is common, then 10 minus 2 factorial value is 2. So answer is 9 factorial into 8. So observe answers 8 into 9 factorial. That third option. Sometimes check options carefully. 8 factorial into 9 factorial there, but answer is 8 into 9 factorial, not 8 factorial. That's why you observe options carefully. Right? Okay. Next one. In how many ways can 5 boys and 5 girls be seated in a row so that boys and girls alternate? So, equal number of boys and equal number of girls. So, 2 boys and 2 girls means boy, girl, or girl and boy. Like this we can. So, 2 into 2 factorial into 2 factorial. 3 boys and 3 girls means 3 boys and 3 girls means 2 into 3 factorial into 3 factorial. We can arrange them alternate. 4 boys and 4 girls means so 2 into 4 factorial into 4 factorial. In the question, 5 boys and 5 girls is given. Nothing but 2 into 5 factorial into 5 factorial. 2 into 5 factorial value 120 into 120. 120, 120, 240, so 144 into 2. 28800. This is the answer. 28800 is the answer. That's it. 10 boys and 10 girls are there. 2 into 10 factorial into 10 factorial. That's it. Very simple. Suppose boys and girls are not equal. Suppose 1 boy, 2 girls are there. Only possibility way. Girl, boy and boy. Sorry. Girl, boy, girl. So 1 factorial into 2 factorial. That's it answer. Suppose 3 boys, 4 girls. Now answer is 3 factorial into 4 factorial. Only one way is the possible. Suppose 5 boys and 4 girls. So 5 factorial into 4 factorial. That is the case. Suppose 3 boys and 6 girls. Here it is not possible. We discussed already. Why means definitely there is a chance of 2 girls adjacent to each other after arranging that 3 boys and 6 girls in alternate. So it is not possible to arrange them in the alternate. Either both boys and girls are equal, then we arrange them alternatively. Otherwise, difference is equals to 1. It is also possible to arrange them in the alternative. Right? Difference is more than 1 between the boys and the girls means definitely it is not only for boys and girls. Maybe some cases vowels and consonant. 5 vowels and 5 consonants are there. How many ways we can arrange them in the alternate means 2 into 5 factorial into 5 factorial. So question may be framed in different numbers, even numbers, odd numbers, or boys and girls, vowels and consonants, whatever it is. So alternative arrangements means like that. In how many ways can 8 boys and 7 girls be seated in a row so that they alternate? 8 boys and 7 girls be seated in a row. 7 factorial into 8 factorial. No need to solve this. Already we discussed just now. So that's it. In how many ways can 6 Indians and 6 Englishmen be seated along a circle so that they are alternate? Yes, okay. Circle and so that they are alternate. Now we will look into that. Suppose n members arranged in a circle in how many ways means n minus 1 factorial is. You know that n minus 1 factorial. So alternate means first we play right. Any case in the previous case also first we arrange boys or girls in the middle of that girls or starting with boy, starting with girl like that. Here 7 girls are there. First we arrange 7 girls. Gaps are 8. In 8 gaps we can arrange that 8 boys like that. Similarly here you can arrange either Indians or Englishmen first. Suppose if I arrange Indians 1, 2, 3, 4, 5, 6 Indians in a circle in how many ways? 6 Indians I arrange in a circle in how many ways? 6 minus 1 factorial. Nothing but 5 factorial ways I can arrange that 6 Indians. Now, how many gaps are there? Observe. 1, 2, 3, 4, 5, 6. 6 gaps are there. In that 6 gaps, we need to arrange 6 Englishmen in 6 gaps. In how many ways? It is not the circular arrangement. That are the 6 blanks are there. In that 6 blanks, we need to arrange that 6 English men. So 6 Englishmen. So 6 Englishmen in 6 boxes, 6 gaps in how many ways? 6 factorial. So total are how many? 5 factorial into 6 factorial ways. We can arrange alternatively based on that 6 Indians and 6 Englishmen in a circle. Right, very, very important. So in a row, boys and girls are equal, then 2 times of factorial and factorial. Boys and girls differ by 1, there is a chance of arrange them alternatively. But in a circle, or circular arrangements or round table conference, whatever it is. So if boys and girls are two separate, whatever the subjects are given, those two are equal, then only it is possible to arrange them in the alternative. If both are not equal, then it is not possible to arrange them alternatively. Suppose 5 boys and 4 girls. I take that 5 boys and 4 girls. Suppose if I place 4 girls, girl, girl, girl and girl. How many gaps are there? Means 1, 2, 3, 4. So 5 boys are there, but we need to place 4 gaps. It is not possible. So if boys and girls are not equal, then it is not possible to arrange them alternate in circular arrangements. So either circle or round table conference. So when it is possible means only both subjects are in equal number, then only it is possible to arrange them alternatively in a circle. That is also very, very important. Next. A round table conference is to be held between 15 delegates of two countries. Again, round table conference. So total how many? 15 delegates are there. Round table conference is nothing but circle. In how many ways can they be seated if two particular delegates are always seated together? So round table conference are there. So total 15 are there. In general, row how we calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The 2 can form a group. 13 plus 1, 14 factorial into 2 factorial. That's it. In a row, how many ways we can arrange them? Always two particular delegates together means 14 factorial. But in a circle, again 13, that 2 form as a group. Always those two are either here or here or here. Right? 2 definitely consecutively to each other. So like that anywhere. So it is possible. Clear? So anywhere it is possible. Now 14 again same, that 13 persons, that 2 persons, maybe suppose these 2 persons means so thus 2 persons form as a group. 13 plus 1, 14 units. 14 units can arrange in a circular way. In how many ways means 14 minus 1 factorial ways into that 2 particular delegates again themselves shuffled in 2 factorial ways. So answer is 13 factorial into 2 factorial. That is the answer. Very, very important again. So same in a circle always come together in a circle. So same type of always come together means similarly we go for that same basic. In a row means just we made that 2 as a group and remaining plus that 1 total 14 units, 14 factorial into 2 factorial. Similarly here also 14 members can be arranged in a circle in 13 factorial ways only because it is a circle, and that 2 again shuffled themselves in 2 factorial. That's why 13 factorial into 2 factorial. This is the answer. Right? Next one. In how many ways can the letters of the word civilization be rearranged? Civilization. Just question read once again. Civilization be rearranged. Now civilization total number of letters are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 factorial divided by, right, repetitions. I. 4 i's are there. So that's why divided by 4 factorial. That's it. 12 factorial by 4 factorial ways. This is the answer. But just read question. Rearranged means we are no need to count civilization word again. So out of 12 factorial by 4 factorial minus 1. This is the actual answer. Why means so we need to subtract that civilization word. They are asking about rearranged. Total arrangements are how many means 12 factorial by 4 factorial. In this total words, definitely one word civilization is also present. That's why we subtracted that one from this. Then this is the 12 factorial by 4 factorial minus 1. This is the correct one. So rearrange means you need to subtract one word. What that one is nothing but whatever the given word. That is the case. Next one. In how many ways can the letters of the word director be arranged? so that all vowels are never together. Simple. Director. So total 1, 2, 3, 4, 5, 6, 7, 8 words are there. 8 letters are there. All vowels never come together. How many vowels are there here? I, E, and O. 3 vowels are there. That's why I form these 3 vowels as a group, and combinedly considered as a single unit. Now consonants are 5 plus that one group 6 total. 6 can be arranged in how many ways means we know. 6 factorial ways. Here first I am taking vowels together. Vowels together 6 factorial into that 3 vowels can be arranged themselves in 3 factorial ways. That's clear. 6 factorial into 3 factorial. It's clear. Now what they are asking, all vowels are never come together means so you need to subtract from total minus vowels come together. Vowels come together. Again, it is not over vowels come together. Some repetitions are there. I, E, O, okay, but R is repeated 2 times. That's why you need to divide by 2 factorial also. This value, I simplify this here. 6 factorial means 720. 3 factorial means 6 divided by 2. 2 1 so 2 3 so 720 into 3. So 2160. These are the different words arranged by using the all vowels together in the director. So total R how many means total 8 letters can be arranged in 8 factorial. 2 R's are repeated, that's why 2 factorial. 8 factorial value 40320 divided by 2 2160. So you need to subtract the 2160 minus 2160. Nothing but 18,000. This is the answer. 18,000. Simple. How many ways can all the letters of the word director be arranged so that all vowels are never together? All vowels are never together means total minus all vowels together. Total are 8 factorial by 2 factorial. Why by 2 factorial means 2 R's are repeated here. So observe here R and R. 2 R's are repeated. That's why by 2 factors. Similarly, all vowels together means 3 vowels form as a group and considered as single unit. 5 plus 1 6 can be arranged in 6 factorial. The 3 themselves are arranged in 3 factorial. But again in this 5, 2 R's are repeated. That's why by 2 factorial value is 2160. After differentiation, after taking difference of those two, we get 18,000. Words can be arranged by using that given condition. So very, very important again. All never come together, all together. All never come together means total minus all come together. That's it. How many words can be formed with the letters of the word Pataliputra without changing the relative order of the vowels and consonants, right? Pataliputra. So, Pataliputra, how many words can be formed with the letters of the Pataliputra without changing the relative order of vowels and how many vowels are there? A, I, U, A. 5 vowels are there. How many consonants are there? P, T, L, P, T, R. 6. Total 11 letters are there. But here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So vowels occupies the same position. Means here vowel. That 4th position vowel. 6th position vowel, 8th position vowel, and last position vowel. In the middle of these consonants. So same, but shuffle. That 6 consonants shuffle themselves. That 5 vowels shuffle themselves again. That is possible, but that position of vowels and consonants always same as the original word. Right now. 6 consonants can be arranged in how many ways? 6 factorial. 5 vowels can be arranged in how many ways? 5 factorial. That's it. But some repetitions are there. That's why you need to. So 2 P's are there. Just observe consonants. 2 P's are there. That's why I divided by 2 factorial, Pataliputra, 2 P's are there. Then T and T, 2 T's are also there, consonants. So that's why again I write 2 factorial. Next, L and R different letters. Okay, leave it. Next, observe that vowels A, I and U are different, but 3 A's are there. That's why I write 3 factorial. So vowels can be arranged in 6 factorial by 2 factorial into 2 factorial, and consonants, vowels can be arranged by 5 factorial by 3 factorial. Consonants can be arranged in 6 factorial by 2 factorial into 2. Total 6 factorial means 720. 5 factorial means 120 divided by 2 factorial. 2 factorial 2, 3 factorial 6. So 2 ones 2 60s, 2 ones 2 30s, 6 ones 6 5s. 720 into 5. So value is how much means 3600. That is the answer. So total how many words can be formed means 3600. So consonants positions are always same and vowels position also same. But that vowels, so instead of A here, I, A, U, A, like that. So U, A, I, A. So like different words may be possible. So like that, how many total number of words can be formed according to that condition means 3600. Consonants and vowels are remains unchanged their relative order. That is important. So their relative order are same, but you need to shuffle any vowels and consonants among themselves and how many ways. Again, this is also some important question. Right. How many different words can be formed with the 5 given letters? Different words can be formed with the 5 given letters, which 3 are vowels, and 2 are consonants. Total 5 given letters. Total 5 letters are given. 3 are vowels and 2 are consonants. No 2 vowels being together in any word. No 2 vowels being together in any word. So no 2 vowels means first we arrange consonants. Yes, clear or not? So I am going to arrange consonants in how many ways? 2 factorial. Now gaps are how many? 1, 2, 3. 3 gaps are there. You need to arrange 3 vowels. So 3 vowels in 3 gaps are how many? 3 factorial. 2 factorial means 2. 3 factorial means 6. 2 into 6, just 12 ways. That is the clear. Out of 5 letters, 3 are vowels, 2 are consonants. No 2 vowels being together means we write like this. So first we arrange that consonants, then what vowels will be filled in that gaps. Suppose here no 2 consonants are being together in the word means we arrange first vowels actually in 3 factorial ways. Now gaps are how many? 4 gaps are there. In that 4 gaps, we need to arrange 2 consonants in how many ways means 4p2. 3 factorial value is 6, 4 into 3. Total 72. So that is no 2 consonants. No 2 consonants being together in the word. So question is framed like that means answer is 72, but according to our given question, answer is 12. Yes, next one. Very simple actually. So only application is the matter. Next one. How many different words can be formed with the letters of the word pencil when vowels occupy even places? Right. Pencil. How many letters are there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it is the given letter, given word is pencil. When vowels occupy even places, vowels are how many? E and I. 2 even positions. Even position. Second, fourth and sixth positions are even position. So 3 even positions are there. But how many vowels are there in the given word? 2 vowels are there. two vowels can be arranged in three gaps. In how many ways means? 3p2 ways. So vowels are arranged. But now how many consonants are there? 4 consonants. How many gaps are there? 4. Just observe here. We used any two places, either these two or first and last two. We used only any two of the three means definitely one is vacant. Already 3 are vacant at odd position, that one. Total 4 vacant positions are there. In that 4 gaps, we we insert that 4 consonant. So 4 consonants in 4 gaps in how many ways means 4 factorial ways. Very, very important. Right. In the question they are asking about vowels occupy even place. That is given means consonants may also occupy even places or may not occupy even places. So we don't have a clear judgment for consonants. Only for vowels that must be always occupy even position. So out of the 3 even places, we use any 2 places by 3p2 ways. Then 1 vacant is there, again 3 odd positions, total 4 vacant positions. We need to insert 4 consonants in how many ways? 4 factorial. 3p2, 3 into 2, 4 factorial, 24 into 6, 144 ways. Total how many ways we can? Means 144 ways we can arrange based on that given. Again, this is also important. Even places means right, no need to always even positions are occupied with vowels. Maybe according to that conditions, whatever the number of vowels are there, that vowels occupy even position, but consonants may or may not occupy even positions according to that given number of it. If 3 and 3 means 3 factorial into 3 factorial. That's it. In this what actually 3 vowels means 3 vowels can fill in that 3 positions at 3 factorial way, remaining 3 factorial way. Like that we can solve. Next. A library has 2 books, each having 3 copies, and 3 other books, each having 2 copies. Suppose book name is A, B. Right? Okay. A library has 2 books, each having 3 copies. A book is 3 copies, B book is 3 copies, and 3 other books, each having 2 copies. CC, DD, EE. 3 other books are having 2 copies. In how many ways can all these books be arranged on a shelf so that copies of the same book are not separated? Copies of the same book are not separated. I mean, these 3 can considered as a unit. It is also 1 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 unit. Total how many units are there? 1, 2, 3, 4, 5. So 5 units can be arranged in how many ways? 5 factorial ways. Again, is there any reshuffle or rearrangement is possible? 3 books are identical. If you reshuffled also, you can find out visible that same way. You can arrange in how many ways? 3 factorial. 3 are repeated by 3 factorial. 3 factorial by 3 factorial means 1 way. Here also 3 factorial by 3 factorial 1 way. 2 factorial by 2 factorial. So like that, remaining all are 1 way, 1 way, 1 way. Again, rearrange themselves in 1 way only. That's why total how many ways are there means only 5 factorial, that is 120. Right, so many confused here, that's why. So each book having 3 copies, like that 2 books are there. Each book having 2 copies, like that books 3 are there. Right, after analyzing that statement, then all arranged in a shelf, but same copies of book are not separated. That's why. So all 3 at a card, all 3 at a group, 2 at a group, 2 group, 2 group. Then 5 units arranged in 5 factorial. But those 3 books and 2 books arranged themselves again in how many ways means only 1 way. Why means all are identical, similar books. That is the case. Next one. 8 men entered a launch simultaneously. If each person shook hands with the other, then find the total number of handshakes. Number of handshakes of n person. Number of handshakes possible of n persons means, we know that NC2. Hugs, how many means? NC2. We know that. right? So clearly we know that. Why means if two persons meet each other, then only it is possible to make a single handshake. That's why definitely we need two persons at a time, right? So n persons means nc2. Similarly, 8 men entered in a long ceremony. If each person shook hands with the other, then total number of handshakes are how many means 8c2. Nothing but 8 into 7 by 2 into 1. 2 1s, so 2 4s. 4 into 7, 28. This is the answer. Right. After calculating those all permutations, 8c2 means 8 into 7, 56. That is also there in the option. But 8c2 value is how much? 28 into 7 by 2 into 1. N minus n factorial by n minus r factorial into r factorial. Right. This is the simplification of C calculation. So answer is 28. Number of handshakes means right, NC2. In a party, every person shakes hands with every other person. If there were a total of 45 handshakes at the party, find the number of persons who were present at the party. So total handshakes are given, but they are asking about number of persons present in the party. Simple. You go in the reverse case. Take first option, 9C to check. 9 into 8 by 2 into 1. 2 1s, so 2 4s. 9 4s, 36. Wrong answer. Why means total handshakes are given as 45. Then 10 persons are there, then 10C2. Nothing but 10 into 9 by 2 into 1. 2 1s, so 2 5s, 5 into 9, 45. Satisfied. That is the answer. No need to check, verify remaining two options. Say clear, 45 answer. So the reverse question is there. We go from through options, then very easy to find out. So number of handshakes is always NC2. We know that. So based on that, we solve this question. Next one. There are 3 members in a delegation which is to be sent abroad. Right. Question. 3 members in a delegation which is sent to abroad. Total members, total number of members is 7. Total 7 are there. Out of 7, we need to send 3 members to abroad. That is the question. In how many ways can selection be made so that a particular member is always included and excluded? Two different questions. Suppose out of 7, 3 members we need to select means 7C 3 ways. That is the actual answer. But they are not asking about this out of 7, 3. Some conditions are given. Always one person is included and always one person is excluded. So two different conditions. Suppose if I guess always one person is included, a particular member is always included. Suppose one of the student is favorite means, or one of the employee is very very favorite, one of the delegate is favorite. Whoever that owner or CEO trying to always include that particular person because of that concern. So total how many members are there? 7. Already one member was selected, means we need to select the remaining 2 members from out of remaining 6. Clear? So already one member is selected. That's why remaining 6 we need to select 2 persons. So always one is included means we need to select 2 persons out of remaining 6. In how many ways? 6C2. 6 into 5 by 2 into 1. So 3 1s, so 2 3s, so 3 into 5, 15. Okay, 15. Option is not there. Yes, okay. We'll look into it. Second one. Always excluded. Suppose 7 persons are there. We need to select 3 members. So, right, one employee's feedback is not that accurate, that much preferable. That's why always that we are trying to avoid that person. So remaining 6 persons are there. In that 6 persons, we choose that 3 members sent to abroad. So we need to select 3 out of that 3. 6C3. Nothing but 6 into 5 into 4 by 3 into 2 into 1. 3 2 6, 6 cancel, 5 into 4, 20. Right. Change this option. Actually that option 4 15 actually, not 4. 5 comma 20. Right. Change that option 15 comma 20. This is the correct answer. Right. So 15 comma 20. Option is 15. Right. So these are the two. Always one particular member is included means so we need to select 2 members remaining out of 6. But always one is excluded means so we need to select the 3 members out of 6. 6C3, 6C2. Simple. Right.